Welcome to Chapter 2, and we're going to be talking about atoms, molecules, and ions. So the first part, if you do your reading, you'll read about the atomic theory and the law of multiple proportions, the discovery about the structure of the atom. You'll read about radioactivity, the nucleus, the electron, and then in section 2.3, it's going to talk about the atomic number, the mass number, and isotopes. And so you will need to be familiar with this, which is the X is the element symbol. And then if you have A is the atomic number. And that is not the atomic number. You know, I want to say A because I want to say A is the atomic number because of the A, but this is actually the mass number. And you need the formula mass number equals neutron plus proton. So let's put that in a box of formula you need to know, and we can even highlight that. So the mass number of the element is the neutrons plus the protons, and then Z here is the atomic number, and that is the same thing as the number of protons. Now I think of the number of protons as like the Social Security number of an element. So you can be identified by your Social Security number, you can be identified by your name. Same thing with the atomic number. So if you look at your periodic table and you see the atomic number 6, you see that is element number 6 is carbon. And that will always be the case. If you change the number, and so this is the number of protons, and protons are found in the nucleus, and the mass of a element is in the nucleus. And the nucleus is kind of the center here, and it's almost like the size of like a marble inside like a big stadium on the 50-yard line. It's so small, but it has all the mass. And then you also have neutrons. So the neutrons are here. So your mass is made up of neutrons plus the protons. And so if you look at your carbon, if it's carbon 12, so if you have something like this, which is C means carbon, and it has proton number 6, then the 12 is your mass number. And so that's going to be 12 equals neutron plus 6 protons. And so the number of neutrons would be 12 minus 6. So the number of neutrons here would be 6. So neutrons, I'm just going to put as an open circle in the nucleus because they have no charge. So they're neutral. So neutrons are neutral. And I think of the neutrons as kind of like the sticky glue that holds the protons together, because how else can you have 6 protons also small when positive charge repels positive charge? So the neutrons actually, and you'll find that radioactive elements have not a 1-to-1 ratio of neutrons to protons, and those become radioactive. Okay, the electrons for a neutral, no charged atom, so like carbon, if it has 6 protons, then it better have 6 electrons. And electrons are out here in space. So 1, 2, 3, 4, 5, 6. And so this is the structure of an atom that belongs to carbon. Now, if you change the number of protons to 7, now you have nitrogen. And nitrogen's chemical element is 7. And so if you have something like as nitrogen 14, then it has 7 protons and 7 neutrons. And then if it's neutral, it has 7 electrons. So we're going to be doing problems like that. And so if you go to your checkpoint problems, let's pick a few in section 2.4.1. Which of the following series of elemental symbols lists a non-metal, metal, and metalloid? Okay, I'm not going to do that problem, but what I want you to do is look at your periodic table. You have one on page 50, and I want you to use colors. And if you use colors, you can use highlighters, or you can use colored pencils. And if we had a lot of time in class, I would do this and make a legend for like alkali metals. How about alkaline earth metals? Earth metals. Make for transition metals, metalloids, and do a color coded, like, so like you might want to shade these a light red, maybe these are green, and trace them, but don't cover it where you can't actually see all the information on your periodic table, but do something like this. And at the end of the week, if you show this to me, I'm going to give you a +1 for your quiz problems for the week, okay, for week 2. So I want you to do that and stuff like that. So that's 2.41. Let's look at your next problem. Which of the following elements would you expect to have properties similar to those of chlorine? I'll do that one, 2.42. And so if you have the same group, which is vertical, they're going to have similar properties. So if you find chlorine, you'll see that chlorine is a halogen. You need to learn those nomenclature, halogen. And so another halogen would be fluorine. So that would be B, fluorine. Okay, so let's go on to section 2.5. 2.5 is the atomic mass scale and average atomic mass. Now, this is AMU. I don't care for AMU. I know I should because Gen Chem and all this stuff. We'll talk about it a little bit. But AMU is the same thing as grams per mole. Okay? And so this is your atomic mass. So if you look up at carbon, and this is what you're going to need to do when you're doing your reactions and stoichiometry. If I look up carbon and I see a number for its mass, so I see carbon is proton number 6, so it's element number 6, and I see another number, 12.010, yeah, 01. Okay, you can say that's AMU, but I also say 12.01 grams equals 1 mole. And I like those conversion factors. Okay, and this is when we're going to talk about this later, but I like to go ahead and introduce it because it's very powerful. It's going to be a toolbox, and those are your conversion factors. 1 always goes with mole. So, and this is your average atomic mass. And average atomic mass means that there's different carbons. So, and how did they even come up with the mass of these? Well, they just made carbon is the most abundant organic molecule. Everything's made of a carbon. They said, let's make carbon 12.00 atomic mass units. And then how they figured out that hydrogen is like 0.083985, the atomic mass is that lighter. So like if we figure out someone is so tall and we pick that person, we're saying, okay, we're going to make you 12 meters, and then we can see someone else is half, you'd say, well, they're 6 meters. So this is times 12.00 atomic mass unit. And if you do that percentage, you see that it works out to be 1.0078 AMU atomic mass units. And so everything's relative to carbon. And that's how these numbers came about. But now carbon has several isotopes. There's carbon 12, there's carbon 13, and there's carbon 14. And there's actually a certain percentage of carbon 14 if you're living that's exchanged in your tissues. in your air, your carbon, you breathe out carbon dioxide, and that's how carbon dating is. So anything living that goes through a carbon cycle can be dated based on the percentage of carbon-14 in their tissues. And so I know we have some forensic scientist people, and so measuring carbon-14 would date, like if there was a dead body, how long that body had been dead or decayed. So, now, what are these? These are all carbon. So if they're all carbon, that means they all have the same number of protons, which is 6, but they have different masses. And you see how I like to write them with the dash? I do that because I can't remember this whole atomic mass and which one goes up here, but I can right now just because I'm teaching it. But on a regular day, I can't remember if it's on the top or the bottom. But we understand this is another way to write it. Okay, and so the 12 means, or the 13 and 14 is the mass. So mass equals neutrons plus protons. So your mass is going to equal, for like 14, equals number of neutrons plus 6. And so here, 14 minus 6 is that 8? 8, 9. Yeah, 8, 9. So this has 8 neutrons, 6 protons. This would have 7 neutrons, 6 protons. This would have 6 neutrons and 6 protons. And so if they have the same number of protons, but they have different number of neutrons, hence a different mass, these are called isotopes. And isotopes were really figured out when the introduction of mass spectroscopy. And it's a way to see the different masses of different elements and their abundance. And so this is how we were able to come up with the different average atomic masses. So we're talking about how to calculate average atomic mass. And so let's work a problem in your checkpoint. So we'll do problem number 2.52 is something you could probably see on your exam. So I will star that. Okay, the two naturally occurring isotopes of antimony, 121, and it gives you the percent, 57.21%. And you also have 123 antimony, SB, 42.79%. And they have masses. So this is your percent abundance. And this is your mass. And they actually give you the full atomic mass unit, 120.904 AMU and 122.904 AMU. What is the average atomic mass? And this is where you're going to have to apply your formula, and that's basically you want to do the percent abundance, and you have to divide that by 100 times your mass of the isotope, AMU. You put that in parentheses plus the percent abundance. You have to divide that by 100 times the atomic mass unit of that isotope. And sometimes you can have like 5 or 6 of these, and this is your average atomic mass that you want. Okay, so this is what you want. So the percent abundance here, I'm just going to move the decimal by 2. 0.5721 times this number, 120.904 AMU. And then we're going to add that to the next one, 0.4279 times 122.904 atomic mass unit. And then we get our calculator out. And I always write the numbers down because if I have a problem with my calculations, it just saves me some time and I can see it. So this is 69.169178.4, and I do write them all out when I am working the problem. And then I round at the end. So 0.4279 times 122.904, because you saw what I did before. I wrote the wrong number. 52.590621 and I'm just going to go ahead and add 69.1691784 and I equal that out and that gives me 121.7598 and I'm going to see now we're going to round to two places 121.7 and because of this 9 here I'm going to round that 5 up to a 6 atomic mass unit and I see that I have an answer C and then you can check to see if that is correct. It should be correct. And so that is one that you would have to be able to do the average atomic mass. All right, so the next section, the rest of these sections are naming. So let's work on naming. Okay, so we're in section 2.6. We're going to do ions and ionic compounds. And we'll be doing some naming. Okay, so we've already talked about the number of protons, neutrons, and electrons in an element. Now, an ion can either be a cation, and that's a positively charged atom, or, and think about a cat. Yes, I had to do my little mnemonics here. My kitty cat. Cat, it's got an eye on you. All right, let's make a freaky cat. That's my cat. Cat ion. And that's positive. We got, do we have happy feelings for cats? We're positive. And then you got an onion. An onion, it makes us cry, right? And this is an onion. It's not really an onion, anion. Okay? And an anion is negative charged. Okay? So let's look at the chlorine ion and let's look like a sodium cation. Sodium cation, let's do the number of protons. Well, what number is it on the periodic table? Number 11. So it's 11 protons. Number of neutrons, well, you'd have to get the mass. So if I put a 23 up here, now you could figure that out because mass equals neutrons plus protons. And the mass is 23, the number of neutrons plus 11. So now neutrons equals 23 minus 11, which is 12. So that equals 12. Now the number of electrons. We have a charge. Okay, so it has to have, since it's positive, has to have more protons than electrons. And it better have 1. So it would have 10. So it'd have 10 electrons and it has 11 protons. And so that extra 1 will give it a positive 1 charge. Okay, so when you do the chlorine, the number of protons, we figure out where chlorine is on the periodic table, is element number 17. And then we say the neutrons, and once again, I'd have to give you the mass. I'm going to give you the mass of 37. And I put it in the wrong place because I told you I would, folks. So let's give it a 37 up here. Okay, so we know mass equals neutron plus proton. So 37 equals N plus 17. N equals 20. Is that right? Okay, so there's 20. Now the number of electrons, it's negative. So if it's negative, then it has to have more electrons than protons. So if it has 17 protons and it's a negative 1, it has, nope, that's not right. Not 16, it should have more. It should have 18. So if it has 18 electrons and 17 protons, it would have 1 negative charge. So that is how we know that. Now on your periodic table, I want you to know that group 1, groups are vertical. Group 1 will have a positive 1 charge. Group 2 will have a positive 2 charge. And these are the representative, I don't even know what that means, okay. But these are A's, and then you'll see the B's. The B's are the transition metals. And transition metals typically have different charges. They form different charges. And these charges are formed when they're in a compound. And that's what we're going to. We're going to talk about what's the name of the compound. So they have different charges. Now the transition metals that don't have different charges are silver. Silver is always +1. Cadmium is +2. Zinc is +2. Notice they're all at the bottom here. And then, so those are like the 3. You might want to capture that on your periodic table that you were coloring and stuff like that. Group 3A is going to be a +3. So, like aluminum is group 3. That's going to be a 3+. Now you do have your metalloids, so you see all those. These are metals. Metals give up electrons. Metals always form positive, always. They always form positive charge, and 2/3 of the periodic table are metals. Okay. Now, your nonmetals are on the other side of your metalloids. And the metalloids have, there's like this stair step here, and you want to capture that on your labels. The metalloids have metal properties and non-metal. And so when you get on the other side, you get the nonmetals. And the nonmetals form negative charges. They're anions, negative charge. And that's because they'll actually accept electrons. So carbon is 4- because it's group number 4. 5A, group 5, like nitrogen, is 3-. Oxygen is a 2-. Fluorine is a 1-. And then the group 8A, they are inert. They're noble gases. The noble means you don't interact. No interaction. So they're not going to form compounds. So they don't give up electrons or take electrons. That's what an ionic bond does. Ionic compounds are always a metal, and you do the metal first, plus a nonmetal. And the metal will be a positive charge, a cation, because it will give its electrons over to the nonmetal. And that will become a negative. And that's an ionic compound. They don't share. They give and take. And so halogens are 1-. These are called calogens. Those are 2-. And so those are the charges that they typically do. When you get in the transition metals, they can be different ions. Okay, and we're going to talk about naming those compounds. I'm going to go straight into some naming examples on your checkpoint, and we'll learn from there. Okay, so I'm doing checkpoint problem 2.61. The correct name for lead sulfate. Now, this is a polyatomic. So you have some polyatomic ions. You need to memorize them. So table 2.3 are your polyatomic ions. I'd make sure I had maybe that photocopied. Okay. Notice those are elements that are with oxygen mostly. Except there's one positive, well, you have a few positive, but the real one is, that you're going to see is this one, and that's ammonium. And it's a +1. You have to memorize the name, the formula, and the charge, because you're going to need all of these for problem solving. Your anions, the rest of them are pretty much anions that you need to know. And then let me just give you some help here. So I'm going to try to draw you a picture. And let's see if I can draw this. Okay, what is this? Okay, I don't even know what the tail is. This is Nick. And Nick's a camel. And he's eating. Okay. And he ate. And these things, these are clams. Okay. and he's in Phoenix, Arizona. Okay. And so this is my sentence I want you to remember. Nick, the camel, ate a clam supper in Phoenix, Arizona. All right. So 8. So when you're memorizing your polyatomics, that's how I remember it. 8 is like SO4. It's SO4 2 minus, and this is sulfate. And you have to memorize that. Okay, sulfate. And you see the 8? So these are your 8s, and they have oxygens. And so what I want you to do here is write vowels equal charge in the word, and consonants equal number of oxygen. So Nick is in, and how many vowels? 1. And how many consonants? 3 consonants. Okay, sometimes I get my math language messed up. Okay, so there's 3 oxygens, and it's a charge of 1 minus. And this is called nitrate. And then to go to nitrite, you keep charge and you decrease by 1 oxygen. So this is NO2, 1 minus is nitrite. And that's how you go to trite. Okay, let's try another one. Camel. Camel. This is C. And how many vowels do we have? 2. So it's 2 minus. And how many consonants do we have? 1, 2, 3. CO3, 2 minus. This is carbonate. And let's see, do you have to know carbonate? Usually you don't. Carbonate, you only have to know carbonate. Okay, these are the 8s. That's where that word. Clam is CL. And then how many vowels do we have? We have 1 vowel, so it's 1 minus. And then how many consonants we have? 1, 2, 3. So that's O, 3 oxygens. So this is chlorate. Now chlorate and your halogens, they have like 4 to memorize. So if we want chlorite, we're going to drop the oxygen by 1 and keep the charge. That's chlorite. But now with this, you also got to go up to, if you go up, Cl, keep the charge, increase your oxygen count. This is perchlorate. And then you can also go down here where you decrease the oxygen, keep the charge, and this is hypochlorite. Okay, so you can do that with a couple of those, and you can look at those and kind of gather your thoughts on that. Okay, supper. This is our sulfate. So we have sulfate, S, and how many vowels? U and E, so that's 2 minus. How many oxygens? 1, 2, 3, 4. So this is sulfate. If we want sulfite, we're going to drop the oxygen by 1 and keep our charge. Sulfite, is it on there? Yes, sulfite is on there for one that you need to know. Okay, Phoenix, Arizona. That's our last one. You could just say Phoenix if you don't want to do Arizona. Okay, this is phosphorus with oxygen. How many vowels do we have? 1, 2, 3. So that's a 3 minus charge. How many consonants we have? 1, 2, 3, 4. So that is phosphate. And then for phosphite, it would be PO3, 3 minus. That's phosphite. Okay? So that's kind of a starting point to how to gather those and memorize those. And now let's do some naming of the first one here. Okay, so we still have PbSO4. So you have to recognize that this is a polyatomic and this is sulfate. And you have to know that that's a SO4 2 minus. Now, the metal, so this is a metal. The metal's always first. It's going to have a positive charge. And the anion, this is a polyatomic. So once you memorize that that's the name, you write sulfate. And that always comes last. But we got to figure out what is our metal. Pb, what is Pb? It's a lead. And if you go and you look, this is where you need to know your group number. Lead Pb is located where? It's a transition metal. And transition metals can have different charges. So they're going to need a parentheses for the charge. And this has to sum to 0. So the plus and the minus have to add to 0, or whatever the charge is there, and they're going to sum to 0. So if this is a 2 minus, then we need a 2 plus. So then you're going to put a Roman numeral. So Roman numeral is the charge, and you just write lead. So it's lead 2 sulfate. And you see that is C. Okay, let's work 2.62. What is the correct formula for iron? Parentheses 3 carbonate. Now, a lot of people make the mistake of thinking that Roman numeral is like the subscript, not subscript. So Roman numeral is not the subscript. Subscript is how many of the atoms we have, elements. It is the charge. So what's iron? You got to know that's Fe, and then the Roman numeral 3 is 3 plus. Okay, carbonate, you just have to have that memorized. And remember, that is the camel. So we know that that's CO3 2 minus. But now you want to do a crossover because it wants the symbol. And so you do Fe, and this is a 2. So we're going to need 2 of those. And then carbonate is CO3, and we're going to need 3 of those. And when you need more than one of your polyatomic ions, write these down, these are your rules, then you need parentheses. A lot of people put parentheses when they don't need them, and they don't add them when they do need them. But see, we need 3 of these, so we're going to put parentheses and then 3. And that is iron 3 carbonate. And you got to make sure that these are the lowest, and they usually work out 2 and 3. There's no common denominator. So which one is that? Fe2 parentheses. So that is D. All right, so our next problem is 2.63. Which of the following is the correct formula for nitrous acid? Okay, so for the acids, if you have just a binary acid, so like HCl, now that could be hydrogen chloride. So this is a metal with a, well, in this case, hydrogen is considered, could be considered both nonmetals. So we have, but whenever you have just like, this is chlorine, if you found it on the periodic table. Okay, so you drop, when it's in a compound, you drop the INE and you add IDE. So this could be hydrogen chloride if it's in the gas phase. But if you put this in water, it becomes an acid. And so then you have to write hydro, and the I becomes ic acid. So hydrochloric acid. And that's if you just have a binary. And binary is just two elements. See, two capital letters. So two capital letters. But if you have a polyatomic, so like nitrous acid is H, well, I can just do HNO3 is nitric acid. Okay, so nitric acid. Notice that there's no hydro. And that's because we have three. So you have three capital letters there. You have three elements. Okay, so that should tell you you're not going to have hydro. And so this is NO3, 1 minus is nitrate. Okay, it's one of those polyatomics. Now, acids have the hydrogen in front. So instead of other cations, it has a hydrogen, and that's what makes it an acid. So you have to recognize that. So this has no hydro because you only do that if you have two elements. We have three elements here, so we've got to go to our polyatomic. So this comes from nitrate, and so we're going to drop the 8 and we add ic acid. So this would be nitric acid. But that's not what it's asking for here. It's asking for nitrous acid. Nitrous acid comes from the ite. So you remember how we get nitrite? So we always start with nitrate, and then we're going to drop the number of oxygens and keep the charge. So we drop the number of oxygens and we keep the charge, and this becomes nitrite. And then, okay, moving on to naming. You have to practice this, folks. What is the formula for nickel 2 nitrate hexahydrate? Okay, so these are your prefixes, and they're the same prefixes you need for your nonmetal with nonmetal. So you need to memorize that. Hexa means 6. So, and hydrate means water. So 6 waters, and you put a little dot there. Nitrate, you memorize that is NO3, 1 minus. And that, and then you got nickel, and the Roman numeral is your charge. So nickel is Ni2 plus. So we have to do this crossover here. So and we do our metal first. So nickel's here, and it's going to have one of those because this is 1. And then we're going to need 2 of the nitrates. So I'm going to put that in parentheses because it's polyatomic, and I need 2 of them times 6 waters. And so if you look for that one, you can see that C is your answer. And check these because I'm not checking them. I'm going to check some of them. But okay, 2.65, and you check them at the end of your problems in your book. Okay, sodium nitrite. Now the metals always get their name. So sodium is Na, and you know it's +1. But that's not your formula. You can't have any charges in your final formula, folks. Okay, this is my problem solving. Okay, so when I problem solve, I'm doing these numbers of the charges. But when I actually report my answer, I have no charges. So here's sodium. Nitride comes from nitrogen. Okay, and notice it's an IDE. The IDE at the end means it's an anion. Okay, so it's a charge, and that means that it's just an element, a single element. So it's not a polyatomic, and so it comes from nitrogen, and nitrogen is in group 7, and we memorize that it's a 3 minus charge. So now when we put these together with our crossover, we find that there's 3 sodiums and there's 1 nitrogen. And so that would be sodium nitrite. And that is an ionic compound because it's a plus and a minus. And the answer is C. Now if we do 2.66, we have Hg2CrO4. And you always want to start, anytime you get like a transition metal, you want to start with the anion first. And this, I don't really have a trick for memorizing, so you have to memorize it. And you go to your page on 56, and you see that this is CrO4 is a 2 minus, and it's called chromate. And then this is a mercury 2 plus, and that is mercury that one's kind of confusing, isn't it? Wait, you don't even need to do that. You know that's going to be mercury, and you see that there's 2 of them, so you need 1 because 1 and 1 is 2 plus. That'll give that overall 2 plus. And then you got chromate, which is a 2 minus. So that should be A. Okay, so those are your ionic compounds when you're dealing with plus and minus metals and nonmetals. So you always want to figure out if you have a metal and a nonmetal. And I actually go to my periodic table and I use my pointer finger and I find that out. Now we want to go on to molecules and molecular compounds. These are going to be metals with, or nonmetals with nonmetals. Okay, so we're in section 2.7, and we have a nonmetal plus a nonmetal. So we're looking at the far right of our periodic table. You have a chemical formula. You're going to have a molecular formula. And you're going to have an empirical formula. And the empirical formula is the experimentally determined formula. And the molecular formula is what I like. I'm an organic chemist, and this is going to be the exact numbers. The empirical formula is just your ratio. So your formula is your ratio. So if you need an example, hydrogen peroxide is H2O2. So there, but an empirical formula would be HO because it would be in the simplest terms. Now, you do need to know your prefixes. So I'm looking at table 2.4 and 2.5 on page 62. So make sure you do memorize those prefixes with how many, because now we're not doing charges. And I'm going to say no charges. I'll stress that. So, and it talks about naming simple acids. You do not have to do table 2.7, okay, and organic functional groups 2.8. So don't worry about those. If you do need to refer to those when you're doing your homework, you can. But right now, you just need to recognize if you're going to use these prefixes. So let's look at 2.7.1. You have PCl5. So you need to recognize that phosphorus is a nonmetal and Cl is a nonmetal. And so you don't have to, you know charges, and you need to think prefixes. And so then you write down the first one, which is phosphorus. And then you see that you have 5, so it's pentachloride. So phosphorus pentachloride is B. Okay, so let's look at the next one. You don't even have to worry about that. I mean, I can look at that and see that that's going to be methanol, but you can move on to that. 2.7.3, these are covalently bonded. and covalent bonds, and we're going to learn this later with Lewis structures. So you can go back to those pages, maybe like chapter 11 around Thanksgiving. But these are sharing of electrons, and they're covalently bonded, so they're not forming cations and anions. Carbon tetrachloride. So carbon tetrachloride, let's look at what that looks like. You just write carbon, and then the tetra means 4. So that's how you know you need 4, and that's going to be C. And the empirical formula, don't even worry about that one. Compounds in review, there's a good in 2.8 a flow chart for figuring out whether you have to do an ionic naming or polyatomic ion naming. At this point, looking at your extra problems in the back, I asked you to do 2.4. So if I out of 2.4 and 2.11 and 2.12, 2.12, I will probably ask you to do some kind of matching multiple choice with the scientists and their experiment. So that's probably the most important one there. So you can do that. The problems in section 2.3, we've talked about that. So you should be able to calculate protons, neutrons, and mass number. So work on those. And problem 2.32, I really want you to do that with coloring your periodic table. I can see myself asking you something like that with your periodic table to pick out an alkaline earth metal and multiple choice, and you have to figure out an alkaline earth metal. 2.44, that is calculating percent average atomic mass. You need to do that. We did an example, so you will need to be able to do that. And there's a couple of examples of calculating atomic masses. 2.55, you will have to figure out the number of protons, neutrons, and electrons. And electrons are in the ions. And then all your problems over here, 2.59 through 2.64 are naming. And these are going to be your ionic compounds. So we've gone over some examples of that. And so you need to do your charges. And then 2.7 section, we're doing molecular compounds. Know the difference between an empirical formula and a molecular formula. And so like C2N2 for problem number 79, that would be your molecular formula. You can just write MF. So your empirical formula would be CN. So that'd be your empirical formula. So know that. And then it asks you to name the binary compounds in 83. And so I'll just do one there in Cl3. So you name your first one nitrogen, just like it's named on the, and then the 3 means trichloride. So you should be able to do that. And then I like the tables. I think the tables are good. You can see the tables in number 99. You might get something like that because your exams will be filled with some multiple choice questions and short answer. And so the table 99 is something you might see for a short answer to fill in. Okay, I will let you work on those. And you also have a table 2.1117.